Welcome to Mastering Machines, where we discover tomorrow's reality.
I want to break down a piece of technology that's kind of always had me confused, but is always heralded by a lot of technical people in the AI field, and that is CUDA. Let's break down what CUDA is and how it came to be. CUDA stands for Compute Unified Device Architecture. It's played a significant role in advancing what's called parallel computing and GPU accelerated applications. And to give more context, parallel computing is a computing architecture that breaks down large tasks into smaller parts and processes them simultaneously on multiple processors or computing units. CUDA was created by NVIDIA in 2006 and officially launched in 2007. Its development was influenced by earlier work in GPU computing. In 2003, researchers led by Ian Buck introduced Brook, the first widely adopted programming model to extend C with data parallel constructs. Buck later joined NVIDIA and spearheaded the development of CUDA. Prior to CUDA, general purpose GPU computing was challenging and required an extensive knowledge of how graphics worked and how to program graphics and the rendering pipeline for those graphics. CUDA made GPU computing way more accessible to a broader range of developers. The reason why CUDA has become so essential to the tech industry is because, one, the high performance computing, it enables massive parallelization for scientific simulations, data analysis, and other computationally intensive tasks. Also, CUDA has really been adopted by the deep learning and machine learning community because it's used with those applications. Then, obviously, it's used for graphics and visualization. It enhances rendering and real-time graphics processing. So you'll see that in a lot of different Unreal Engine type projects. And then also another thing that people don't know about CUDA is that it's used for cryptography. CUDA accelerates cryptographic operations and cryptocurrency mining as well. CUDA has not only significantly impacted graphical processing and rendering, but it also has just expanded the computer science field as a whole and been able to improve a lot of the subsectors under computer science as well. But how does CUDA actually work? CUDA is like a special language that lets computers talk to their graphic cards to do math really fast. They have what's called special functions, which allow programmers to write these special functions, which are called kernels, and these are like instructions for the GPU to follow. And when you run a kernel, it's like telling thousands of tiny workers, which they call threads, on the GPU to do a job at the same time. Once these workers are organized into their teams, which they call blocks, each team can work together on a part of a big problem. And then the GPU has different types of memory. Some are like personal notepads for each worker, while others are like big whiteboards that all the workers can see and use together. Then it moves the data. Before the GPU can start working, you need to send it the data from the computer's main memory. And that's like giving the GPU the materials it needs to do its job. One of the central reasons for using CUDA for a lot of the computer science industry is that it has super speed. And because of all these workers that are doing their jobs at the same time in terms of the GPU, it can finish certain tasks much faster than a regular computer processor. And then after the GPU is done, it sends the results back to the main computer memory so you can see what it did. So that's why CUDA's used so much for a lot of data intensive applications, because it's able to kind of like aggregate all of that memory and GPU power and really get effective outcomes from that particular application. You can kind of think about it as like having a huge team of helpers who can all work on different parts of a big puzzle at the same time instead of just, one person doing a puzzle all alone. That's why CUDA is really essential to the computer industry and why it's gotten so much hubbub in the age of AI. I hope that explains a little bit more about CUDA and why it's important. I might do more of a deep dive on the history of CUDA. Comment below what you think about CUDA, or if you would like me to touch any other topics. Remember, mastering machines, discover tomorrow's reality.